Okay, well, welcome to another program exam solution tutorial for the AQA Comp 1 2013 exam. This was not something that I initially thought of on my list, in my playlist of things that I would do, but I thought I ought to because it's not that hard to do and it'd be quite fun, interesting, and it is a possibility for the diary file, and it's the idea of having changing keys. So my aim is that we investigate the possibility of a non-fixed key. Now this could be for encryption or decryption. It was one of the ideas behind the Enigma machine. It's very common, and it does make decryption much trickier without using a particularly tricky cipher. Certainly for Caesar cipher and n-character stenography, it's dead easy. I'll be honest with you, I can't work out how it would work with a rail fence. You might. I've not spent enough time thinking about it really, but certainly it doesn't make sense to me that it would work for rail fence. Now crucially, for the Caesar cipher, if you think about it, we could have it that for a given message like hello world, the letter H could be shifted by one character, the letter E shifted by 2 characters, the letter L shifted by 3 characters, and as long as you knew the starting point for the message and the upper and lower bound of the key, you could still decrypt it. So I'm making the usual assumptions, plus the fact that you're not at the point where you just want to run away and hide. So let's have a think about some patterns. The easiest one would be, let's have 2 limits between 3 and 6. So we just go 3, 4, 5, 6, 3, 4, 5, 6, 3, 4, 5, 6. Or actually for Caesar cipher, we could just go between 2 and 26 and just keep cycling around that. We could also just alternate between 2 values, so the H gets shifted by 7, E gets shifted by 4, L gets shifted by 7, then the next L gets shifted by 4, then the letter O gets shifted by 7 again. So that would work, or 3, or whatever, however many I like really. And they of course could be whatever numbers I like. The next thing would be that we have a pre-decided sequence that we shift through. So in this example here, I've gone, the first character will be shifted by 2, then by 9, then by 5, then by 8, then the next character by 3, sorry, the first character by 2, next character by 9, next character by 5, next character by 8, next character by 3, the next character by 5, and then I start the pattern again. Oh no, I don't. I've got another 2 there. And then another 4, and then I start the sequence again. So you get the idea. And that sequence could be as long or as short as I liked, just a pre-known sequence that we're just flicking through and just repeating until we get in the message. Then the final sequence is that we could use an irrational number, and we just keep going. And we use one of the ways of actually generate. You could use pi, as I've done here, or e, or any of the other irrational numbers that I just keep working my way through. As long as that number is held in the programming language or the computer, as long as it's a number that the computer can reliably generate to a reasonable level of precision, you can make use of it. As always, new menu item, new case option, and then really all you're doing is creating a loop that will dictate that current value for n. Now okay, there'll be a little bit of processing for the different methods we've done, but it's only going to be generate an index and then somehow access an element of a sequence, and that could be using modulo arithmetic, or it could be using an array with a preset sequence, or it could just be taking a particular digit from an irrational number. And then once we've got that particular key, we'd decrypt as usual. But obviously we're having to do it a character at a time, which does make it a little bit tricky. I'm not going to do the code for that now. Obviously there's only a couple of days left for the exam, but you're going to have to wait till tomorrow. That'll be the Sunday afternoon for me to actually generate the code for that. But I will do for a couple of those options, and of course if anyone else wants to beat me to it, please feel free to put a link on the comments, but I will solve that problem. And feel free for you to try yourselves. It's not massively hard. It's actually quite similar to the force n brute force type methods we're using. Okay, hopefully you found that insight useful, and I hope you're looking forward to my solution for that.